Hello, and welcome to this overview of Chapter 11 on the topic of the introduction to data mining. Data mining is, in a way, looking at data to make sure it's foundational to the use of analytics. Big data comes into many forms, as big data is multiple sources of all kinds of data, and we need to manage that data to ensure that it provides a value to the analytics we're looking to provide in the organization. So the terms of artificial intelligence, machine learning, and data mining are all used interchangeably. However, their definitions overlap with no clear boundaries. They describe applications of computer software used to obtain insightful solutions that traditional data analysis techniques may not be able to achieve. Data mining is an advanced data analytics set that we take a step further from traditional baseline analytics methods and go further into understanding the data at its root to find out correlations and overall insights that we may not develop with rudimentary analytical methods. In a very broad sense, artificial intelligence is used to describe computer systems that demonstrate human-like intelligence and cognitive capabilities, such as deduction, deducing to certain insights, using inferences, or also pattern recognition, finding a pattern in data that we may not be able to do with the human eye, and interpretation of complex data. Further, machine learning describes techniques that integrate self-learning algorithms. So we're still going to have the ability to use an analyst view and use our view of that, but the softwares out there allow us to mine data a little bit deeper and faster to derive insights to make real-time decisions. It's an application of artificial intelligence that allows the computer to learn automatically without human intervention or assistance. It's also designed to evaluate results and to improve performance over time. Machine learning techniques can uncover hidden patterns and relationships in data. Machine learning can absolutely give us new views that we never thought of before or really validate assumptions or hypotheses that we initially had. Using self-learning algorithms to evaluate results and improve performance over time is critical. Continuous improvement of our business strategies rely on the fact that there's lots of data getting to our organization data sources on a regular basis. So data mining it on a regular basis to monitor real-time performance is critical. Now, data mining at its core describes the process of applying a set of analytical techniques necessary for the development of machine learning and artificial intelligence. So artificial intelligence and machine learning is the operation of managing that data and mining it. Where data mining also needs us to have the ability to look at things in a context of blocking certain data sets with each other to find those patterns or recognitions. Data mining is often recognized as a building block of machine learning and artificial intelligence. As stated before, it uncovers those hidden patterns and relationships, and it gains insights and derives relevant information to help make those decisions. Data mining techniques are used for data segmentation, patterns, classification, and even predictive analytics. Data mining is a very complex process, though, of examining data and applying those analytical techniques to gain valuable insights. It requires a systematic approach to managing and conducting data mining projects. You generally need some advanced software to help with this. A popular approach is the cross-industry standard process for data mining, or the CRISP/DM method. Although there are other data mining methodologies, many practitioners prefer the CRISP-DM method. It emphasizes business goals and objectives prior to preparing the data and choosing analytical techniques. It gives you a framework to where to go into the data set. If we don't have a clear path on what our objectives or goals are, we could spend time in the data, mining it, on things that may not provide value to the organization. So following the CRISP method allows us to find the value in the data as we proceed, knowing the objectives up front. To further explain the CRISP-DM method, it was developed in the 1990s by a group of 5 companies: SPSS, Teradata, Daimler AG, NCR, and OHRA. The CRISP-DM method consists of 6 major phases. The first phase is the business understanding, truly understanding the situational context, specific objectives, the project schedule, deliverables, etc. There's a foundation of truly understanding the current business that you're in and all the dynamics around that. The next step in number 2 is the data understanding. This is truly where you get in there and actually truly understand the data you're collecting the raw data, where it's coming from, the preliminary results, and potential hypothesis in the data. It's basically having a foundation of understanding your data. Number 3 is data preparation. This is where you actually prepare the data for analysis or cleansing. You record and variable selection, you wrangle the data and cleanse it. The next step is modeling. Modeling is selection and execution of a data mining technique to convert and transform data to formats or types needed for certain analysis, document assumptions, and cross-validation. What this means is you're actually performing an analytical model, the method that you want to use to analyze the data, a clustering analysis or some type of segmentation analysis, etc. But really, it's about providing the right data analysis for the right objective. And at the end of this method, you're actually evaluating the results. Evaluate the performance of competing models. Select the best models, right? Running different model variations in business analytics is okay. Not one model is going to give you the exact results that you may think you're looking for, or you can compare and contrast results in different data models to make sure that you're getting the results or validation that you're looking for. Finally, deployment. Develop a set of actionable insights and a strategy for deployment, monitoring, and feedback. Always look for the ways to review the results and assess where to take your strategies further. So this chart provides the data mining overview. Once again, business understanding to then data understanding. Find out which data actually supports your overall business objectives. Prepare that data and then model it in different models that allow you to go to evaluate. And then the modeling and evaluation can go back and forth until you have a place to say you have a results of an analytics that develop an employment or deployment opportunity to drive insights, make decisions, and develop strategies. In the data mining process, it is very important to note that not every step of the CRISP-DM framework is needed for all data mining applications. For example, if your data is already ready to go, you don't necessarily need to prepare it. If you're just running off the same data you already prepared, then you go to the modeling phase. It just depends on where you're at in the particular data analytics that you're running. The data preparation phase, though, is a significant role in the data mining process. An analyst or analytics team tends to spend a sizable portion of their project time in an analytics project, around 80%, on understanding, cleansing, transforming, and preparing data, leading up to the modeling activity. So it is still important. The CRISP-DM methodology is popular among data mining practitioners because it offers a holistic approach to data mining with detailed phases, tasks, and activities. There are other data mining methodologies such as SEMMA for sample, explore, modify, model, and assess, and KDD, knowledge discovery and database. But again, the CRISP-DM method is widely used. Data mining algorithms are classified into two types of techniques depending on the way the data is learned and used. First, supervised data mining. These techniques are used for predictive modeling, more advanced and at times more of a direct target variable, something we know we're directly looking to analyze. Unsupervised data mining techniques are effective for data exploration, dimension reduction, and pattern recognition. The key distinction between supervised and unsupervised techniques is that in a supervised data mining, the target variable is identified. So in regression models, the target variable is the response variable. The historical values of the target variable exist in the data set. Data mining algorithms can examine the impact of predictor variables on the target variable. But on the contrary, in supervised data mining, no target variable is identified. So basically, supervised data, we have a clear intent of what variable we're looking to analyze against, which variable we're truly understanding for a potential assumption or hypothesis and analyzing it further, whereas unsupervised, we're getting in there and actually discovering the target variable as we assess the data. In supervised data mining, some of the most commonly used algorithms are based off classical statistical techniques. Examples include linear regression and logistic regression models. They use predictor variables, x1, x2, and look at those predictive models against the target variable. Earlier in the class, we discussed you must have a targeted variable in a predictive analytics. This is where supervised data mining comes in. A regression model is therefore trained or supervised because the known values of the target variable are used to build the model. The performance of the model can be evaluated based on how the predictive values deviate from the actual values. Common applications of supervised data mining include classification and prediction models. In a classification model, the target variable is categorical. For example, we predict the class memberships of new cases. An example could be classify stock buy, hold, or sell, and what status basically is the stock in. In a prediction model, the target variable is numerical. Predict the target for a new case, such as the spending of a customer. A numerical value predictively, how much are they going to spend, would be an example of a prediction model. Unsupervised data mining requires no knowledge of the target variable. The algorithms allow the computer to identify patterns and relationships in the data without any specific guidance from the analyst. Therefore, it provides more machine learning and advanced technology to help determine the target variable. Unsupervised learning is considered to be an important part of exploratory data analysis and descriptive analysis. Used prior to conducting supervised learning in order to understand the data set, formulate questions, or summarize data. What this means is you can actually do unsupervised data mining techniques to get to the data variable you're looking for to then do a supervised data mining predictive or other type of analysis. So this wraps up the basic overview of data mining and how unsupervised versus supervised data mining have different approaches and insights that can be derived to on how we approach an analytics set of data. Thank you so much for your time in Chapter 11, and we will see you soon.